Okay, right here. Unfortunately, so we are in this case, we are replaced with the little s. Okay, and the little s. There are two ways, two formula for the calculation of this value. Okay, formula one and then formula number two. And then they provide the same number, the same value. And this is more convenient. And in exam, I gave you this, right? In the exam, I gave you this number, the value of this number. Remember? And then you have to fit yourself to attend. Okay, where x is the sample standard deviation, hey, it is always available because we have the data. This is the data you have in your hand. Otherwise, you cannot do anything. Okay? So the distribution rule becomes this. Very similar, but we use a different thing. The here, hey, and ignore the right parts, and ignore this middle part. Okay. What table are we going to use in this table? What table? T table. Okay, and other thing remains almost the same. Okay, before it is C in the previous slide, it is C, right? Now it becomes T with the degrees of freedom -1, correct? And what is different from the previous slide is this standard deviation. This time we use the fake one, not the true one. Okay? But don't worry, the fake one and the true one will be very close to each other. Why? Because we can't even know the answer. When n is large. Yeah. Why? Why? My question is, why the big one base and the true one sigma are very close? When what you said is about the singularity in G and Z, but I'm asking sigma and X, you know? Why? Why are they so close when an N is too long? What? Your answer? Oh, not the answer. And why they are close when n is large? When a sample is big. Okay. By the law of large number. Understand? The law of large number. Put down in your number. Hey, when n is large, then H and sigma will be very close to each other. But the law of large number. Okay? So note that. Know that Okay. Right? Any question? Do you have any question? Any question? So, let me take a comparison here. Here. I insert an extra slide. Okay, this is what we use when sigma is available. Right? This is what we use when sigma is available. So this, and then when I move to the next slide, you will see they are so similar. What what happened? But in the next page, what will be changed? What will be replaced? Here it will be replaced, and later, which one will be replaced also? The critical value from the table, and then you will be using a different table. Understand? So this table, hey, let me switch, hey, up and down. So similar. You see that? Is it similar? What is the difference between these two slides? Yeah. Replaced by this. And the critical values are now from T table. Everything remains the same. Right? So how many formulas are there in the two slides? 6 more. But they can be summarized into one formula. Understand? One formula here. Hey, here the direction is the same as the direction in the hypothesis, alternative hypothesis. Right? When the direction changes, hey, change the direction. All right? When it comes to two-tailed test, hey, there are two directions, bigger and smaller. But can summarize into this one. And so is this. So you see 6 formula here. In fact, all you need to memorize is only one. All you need to memorize is the first one. Okay? All you need to memorize is the first one. If you can do the first one, then you can do the second, the third, the fourth, the fifth, and the sixth. Understand? So here, the formula, very similar, right? It's probably similar. This is quite very similar. You can summarize 6 into 3. But into 3, the 3 you can summarize them into decimal. All you need to do is to change the direction. And value and also the date. Other things remains the same. So and this time it will be P, the population proportion. This is the population mean, but later you will see a formula involving P, not anymore P, and also this. not anymore H or sigma. It will be the standard deviation of the Bernoulli population here. Yeah. The decision rules for the big hypothesis that in case of population problem. Hey. Here. To this. Is very similar to the previous 6 formula. Is it similar? Very similar. Hey. P hat is in fact is actually X bar. It is X bar. The same as X bar. Okay? And the mu 0 here is now replaced by B 0. Understand? And the square root of it remains the same. But now sigma is now replaced by the square root of P times P0 times Q0. Q0 is 1 minus P. Are they very similar? 9 formula are very similar. They can be summarized into 1 formula. All you need to do is to replace the thing here, and also the thing here. Right? You got it? Let me switch again. This one. This one duplicate, and this one duplicate. And now let me. Where is it? This one here, and this one here. Okay. So we have 9 table now. Now we have 9 table. Hey, then let us look at the first 3. Hey, this is the first 3. These are the first 3. We are learn. Okay, when value of sigma is available, and when it is not available, we go to a different table and use a fake value of sigma. But the form of the decision rule are very similar. Right? What happened? Very similar, right? Is it? Very similar. What about the next one? Next 3, last 3. Very similar again. Very similar. Understand? One. Now, in the next slide, X bar is replaced by P hat, and mu replaced by B, because now it is the population proportion. Understand? And then when it comes to population proportion, P0, the sigma is different. This is the sigma, the standard deviation of the Bernoulli distribution. The Bernoulli distribution has sigma, which can be expressed as the square root of P0 times 1 minus P0. That's the sigma of the Bernoulli distribution. Understand? Okay. Now, and in fact, the 9 formula, 9 decision rule can be summarized into 1. If you can do the first one, then you can do the other 8. All right? If you can do one of them, then you can do the other 8. So now let's okay. I remember this. Hey, I believe you had sent this. You had sent this in the midterm exam. Remember? Remember the midterm exam? What most question? It will be very close to. It will be very close to what? Close to the standard normal distribution. Now let me go to the the midterm exam. The midterm exam here. I ask you the question. I ask you the question here. Yes. Oh no. Yeah, this one. Yep, this one. This problem 7 is related to the slide of the last slide. Okay. Hey, if you divide it by n, then this if you divide this by n, this will be p n, which is x bar. It will be p n. And there is no n here, just p. And if you divide it here by n, then you should also divide it by n here. And then now divide it by n. Okay. Yeah, if you divide it by n, then there will be a square root of n in the lower term and no n here. So let me take you to review. Okay, note that. By the central limit theorem, okay, by the central limit theorem, when x1, x2, all the way to xn are drawn from the Bernoulli P. All right, then x bar minus p will be very close to the standard normal distribution. Okay, where standard deviation of the Bernoulli distribution okay. What is the standard deviation? Standard deviation is often denoted by sigma. So this term is in fact sigma. So the formula is not different from the decision rule. The formula here is not so different from this formula or this formula. Understand?
And P had to equal X bar. When I use 3 lines to denote equal, it means that they are exactly the same in nature. In their nature, exactly the same. Okay, exactly. You got it? Any question? Do you have any question? So if you don't have any question, then we will look at 2 examples here. Please go to example A-12 in your textbook. In your textbook here. Hospital infection. Hey, especially during the pandemic, COVID-19 pandemic, the hospital infection is very common during the pandemic, right? Okay. And a medical which page? Now let me see. The page is on. Please go to page. Go to page. Hey. Go to page. Chapter 8. It is chapter 8. Chapter 8. Page 436. Page 436. All right. Page 436. All right. Any question? If you don't have any question, then I will proceed to the example. This example. Hey, a medical investigation claims that the average number of infections per week at a hospital in the southwestern Pennsylvania state, that's in America, is 16.3. Okay, 16 point on average there are 16.3 hospital infection in the Penn State, in the southwestern Penn State. Okay, and then a random sample of 10 weeks. Hey, this time n is 10, which is very small, a small sample. So n is now smaller than 30. 30. So it is a small sample. Okay. Okay, so a random sample of 10 weeks had a mean number of 17.7 infections per week. Okay, so the X bar is now 17.7. Right? The sample standard deviation is 1.8. Hey, this means that when you see sample here, it means it's a fake one because it is based on sample, not the true population standard deviation. Understand? So it is a fake one based on sample, based on the observation. So it is 1.8, which is when you see A's here, then the formula is the new formula. the decision rule, new decision rule, and the table will be T table. Okay? So, the example raises the question, is there enough evidence to reject the investigator claim at the level of the significance? And assume that the variable is normally distributed. What? Oh yeah, normally distributed. Yeah. Okay. Let us take a look. So, mu equal, so the null hypothesis, and what is the question? Is there enough evidence to reject? And put what you want to reject at the null hypothesis, because it is always a negative assumption. You are finding the evidence to reject it. So put what you wanted to reject in the null hypothesis. So what is the question raised? What is the question raised? Is there enough evidence to reject the investigator's claim? Investigator claims that the mean number of infection per week at a hospital is 60 point. So put what you wanted to reject in the null hypothesis. So the null hypothesis is mean number of hospital infection mu equals 60.1. The investigator's claim. Okay, this is what you want to reject. So it should be in the null hypothesis. Understand? And the alternative hypothesis is not equal to 16.3. So this is the one-tail test or two-tail. Two-tail test. Okay, it comes with no direction in the alternative hypothesis. There is no direction. So that's a two-tail test. Right? And in the final exam, I will give you this. And also this. And then you have to obtain this and this. Understand? If I give you this, then you should use this formula here. You should use this formula here. Here. This one. If I give you the sum of SI squared, if I give you this formula, then you should use this and this to obtain this. Okay, I will not directly. I won't be good enough to give you this directly. I will give you this and this, so that such that you have to obtain this by yourself, right? So, yeah, here. Now, the test statistic. Now the test statistics is not C anymore. It is T here. So don't use T here. You should use T. So what is the T value? The value, and this is called the test statistics. Okay, so it is x bar minus mu. Mu is the value under the null hypothesis, and this is square root of n under the value of sample standard deviation. So what is it? It is 1.8. And what is n? N is 10. And this is under the value under the null hypothesis. And this is the observation. It is the mean value based on the observation. And all you need to do is to obtain the fractional value here, and then go to the table. And because it is the degree of freedom is 10 minus 1. And also Not that. It is a two-tailed pattern. So the alpha should be divided by 2. Right? It should be divided by 2. And if you go to the table, you will see the critical value here is 2.262. And the inequality hold. The inequality hold here. You see this? Which means that if the data fall in a critical region, means that which one happened? 1, 2, 3, 4. Which one happened? The third one happened here. This one. This one. Okay. This inequality holds. This one. Understand? This one hold. So you have it falls in the rejection region. So you have to reject the null hypothesis. And note that because it is a two-tailed pattern, the level of the significance should be divided by 2. Okay, you can only use 1/2 of it. Okay. So what is your decision? Reject. Our decision is to reject x0 at the level of the significance alpha equal 0.05. A 10-minute break. 10-minute break. So Ladies and gentlemen, what happened? Hey, do you have any question about the midterm exam? The score and your answer? Anything wrong about the decimal places? Hey. What? Oh, okay. What? What is your question? What, yeah?
My stuff very answer, but
Oh, and what to be? I will pick up the most generous option. There are many ways to bring your points for the multiple choice question, and I will pick up the most generous option. Okay. Ah. Where is the multiple choice question? Oh, here. This one. This is the choice. This one. Which one? I think this is the most. This is the most general one. What? What happened? Eh? Eh? What happened? Eh? What happened to my keyboard? Eh? Eh? Hey, what happened? Oh. Yeah. Okay. Okay, update it. And save. Yep. I have to wipe off the Chinese letter. Eh? Okay. Eh? Oh, I see. Hey, ladies and gentlemen, silence, attention. Hey, final exam. All right. Now, the next example. Please go to page. Which page? Please go to page. Um. Page 448. Please go to this page. All right. Got it? Attorney. Attorney means a law firm. Law firm. Okay, lawyer. An attorney is a lawyer. Law. Okay. An attorney claims that more than 25%, more than, okay, more than 25% of all lawyers advertise. Okay. A random sample of 200 lawyers in a certain city show that 63 had used some form of advertising. Okay. And alpha 0.05 is there enough evidence to support. Okay, this is what you wanted to support. You wanted to support the attorney's claim. Hey, then you should put this claim in the null hypothesis or the alternative hypothesis. Alternative. Okay, this is what you wanted to support. So put it in your alternative. Hey, and then the claim is more than 25%. So I know, hey, if you have a set of 200 lawyers and you have x1, x2, x3, all the way to x200, right? x1, 2, 3, all the way to x200. And each x I is either 0 or 1. It is 0 if the firm, if the attorney does not advertise, and it is 1 if the law firm advertise. It is either 1 or 0. Okay, so what you wanted to get, and the 25% is the population proportion. The proportion of law firm advertise. So and x1, x2 all the way to x200 is either 1 or 0. So x is drawn from the Bernoulli population. Understand? So it is a question of, it is an example about the population proportion. Understand? Population proportion. So the solution x1, x2, all the way to x200. Okay, this is the sample you have in your team. And you see that 63 of them advertise. So there are 63 x which are 1s, right? And 137 of them are 0s. All right. So it is either 1 or 0. Either 1 or 0. Okay. Understand? So what is the p-hat or x bar? Right? It is either 1 or 0. Okay. So what is the sample mean? Sample mean is 0.315. Understand? So the two hypotheses are specified as, hey, don't turn on don't turn up. I should turn it off. I just turn it down. I should turn it off. Oh, it's freezing. Hey, the two hypotheses are specified as, hey, this is the one what you wanted to this is the hypothesis you wanted to conclude. So put the hypothesis you wanted to conclude in the alternative hypothesis. And this one can be smaller than or equal to, or just equal to, okay? So this is feasible. And you want it to support. If the question is, can we support the alternative plan? Okay, so this one should be placed in the alternative hypothesis. Okay. So what is the test statistic? Hey, here I look at a symbol. What did I use? What I'm using is DOT. So we should go to the normal game. Right? If this is the test for the population proportion, it is always CS. It will be never TS. Understand? It will be never TS. It is always the Z. Okay? So the test statistics here is x bar minus v0, and here it is p hat minus v0. And this is the lower part. You see the square root of p 0 times 1 minus p0. It is the population standard deviation of the moving p0. Given that x0 is true, so it is p0. Like what is the p0 here? P0 is 0.25. Right? 0.25. Okay? And now, and the fraction. The fraction is 2.12. And it is bigger than 1.4645. And this is the one cell test. It is the right. Okay, so which one occur? Which inequality hold in the table? Which one? Which one? One? The single one. Right? It is the right cell test. And you see the direction? Bigger? Bigger. Okay, so this equality holds. And the data fall in the critical region. The data fall in the critical region, okay? Here. Okay. So the Z score, Z value here, it is 2.12. And it is bigger than 1.645. And the evidence is strong enough to support his claim. And now we should reject the null hypothesis at the 0.05. All right? Okay. Understand? Any question? And I want you to now, so that's our decision. Hey, can we use a different approach? The p-value approach. Remember the p-value? P-value approach. Hey, in the final exam, I will have you do this test in two methods, using two methods. The first method is the method we see here. The second method is the second method I'm going to use. The second method is called the p-value approach. Yeah. But yeah. Oh, should we do it? Oh, no. Typo. $200. It's 10 in the previous example. Okay, 10 is the number, the sample size in the previous example. So it is 200. Okay. Yeah, the next approach is the p-value approach. Okay, so okay, note that by the central limit theorem, this is what we have learned in the previous hour. Okay, I'm not going to. Okay, the p-value approach. Right? P-value approach. The p-value approach here. Insert. The p-value method. Hey, in the final exam, you will be required to do a test by two methods. Okay, so note that what is the z-score? Z-score is p hat minus p0 divided by p0, 1 minus p0, and a square root of 200. And what is this? Is it 1.12? Is it? Yeah. And the p-value is the area under the standard normal curve right to, this is the p-value, equal 1.12. So what is p-value? P-value, hey, if you wanted to calculate p-value, you should calculate C first. The C value first. Hey, understand? So it is 2.12. So p-value is the area. P-value is the area right to 2.12, right to the C statistic. Okay, so you should go to the table. You should go to the table. Go to the table. The table here, a normal table. Normal table. This one here. Yep. Yep. And 2.12, right? 2.12. Let us zoom in. Yeah, here. Zoom in. Yeah. 2.12 to this column. 2.12 here. It is 0. It is here 0.0170. This number. It is the area right to 2.12. So it is 2.12. Where is my pen? Where is my pen? Here. 2 point, it is 0.01. What is it? 0.170. Okay, this is the p-value. Okay, this is the p-value. Right? The area related to the test statistics. Okay, and so the p-value equal 0.0170. It is smaller than 0.05. I said, I have told you in before the midterm exam, when p-value is smaller, then the test is more, the evidence is more significant. So the evidence is strong enough to support the attorney's claim. Okay. And in exam, you will be required to do the test using two methods. So you have to know how to do the test by the p-value method. All right. Any question? Do you have any question? Any question? Okay, if you don't have any question, then we will go to another hey, in this example, hey, look at this. right? And 0 otherwise. Right? So it is either 1 or 0. Understand? Any question? Do you have any question? If you don't have any question, then I have some assignments for you. Please go to the exercise 17 on page 442. This is your assignment this time. Four for 2, yeah. Exercise 17. And note that there are two alpha. All right. Question 17. All right. Any question? And also, which one? Let me see. Another assignment, another exercise. Yeah. And also as yeah. And also the exercise 15 on page 450. 450. And exercise 15 on page 450. All right. Any question? So two exercise as your are your assignment, and it is due on the teaching assistance time. All right. Any question? If you don't have any question, then we will proceed further. Where such that hey, what happened? This square root of p times 1 minus p0 is the standard deviation of the Bernoulli distribution. All right. And please go to the let me take you back to the midterm exam. The midterm exam here. Yep, this one. This one. This one, I think. It is this one. Hey, where is it? Yep, this one. Which one is correct? Which one? Let us look at the first one. Is the first one correct? Here, is it correct? No. It is correct only when number one is squared and the sigma 2 is squared also. Right? Is the second one correct? No. This one should not be squared, and neither is this. Unknown. It's incorrect. Anyway, so what is the correct formula? Which one? This is not correct either. No minus, it is always plus, not plus. No minus, it is always. Okay? And this one is not correct either. Because the whole thing is not square. It should be the square root of this. Square root. Okay, so which one is correct? This one. So this one is correct, right? The is distributed as the standard root. Right? Don't forget the square root. And it is plus here, not minus. Okay? So E is correct. And which one is correct? Yeah, this one is also this one. Although this is minus, and the variance here should be the symbol here should be plus. Understand? So, and this is what we need next. This is what we need next. Okay. Here, what we need next is here. Now, we will perform the hypothesis testing. Involving regarding two populations. Okay. The first population and the second population. All right. The first population and the second population, and the hypothesis and the hypothesis is about the comparison of mu1 and mu2. All right. And the hypothesis are H0 H1 mu1 smaller than mu2, or mu1 bigger than mu2. All right. And then H0 mu1 bigger than mu2 and mu1 smaller than mu2. And lastly, H0, H1 here. Mu1 equal mu2. And mu1 not equal to mu2. And this, the last one is also a two-tailed test, or equivalently. Or equivalently, H0, mu1 minus mu2 smaller than 0, and H1, mu1 minus mu2 bigger than 0. And the second one is equivalent to this one. Mu1 minus mu2 bigger than 0. Mu1 minus mu2 smaller than 0. And lastly, mu1 minus mu2 equals 0. Mu1 minus mu2 not equal to 0. Okay? So we often convert the hypothesis study into the we convert this one into the this one into the second one, this one into the second one. And we will need this. We will use this in the hypothesis test. Okay? Understand? And now we will need this formula. This one. For this kind of hypothesis testing, we will need this one formula. The one you saw in the midterm here. You will need this formula. Hey. You will need this formula. Understand? And then we will study it next week. Next Thursday. So local time. Local time. Hey, I will double this local. Yeah. What? You like it?
Three ball.
No, just stop it. This time, 1 second, 2 seconds. Go. What happened? Hey. Oh no, not that. Okay. 1 second, 2 seconds, 3 seconds, 4 seconds, 6 seconds, 7. Hang on, hey. Hey, you don't want to double it? Oh, double. Then sit down.
Okay. Double. Double is like a thing. Ôi, trận đấu là tao cái phải cãi gì rồi. Đó. Cái rồi lên rồi.
Yes.
I'm still confused. When do you use one cell test and two cell test? I mean, like what are the
Well, one tail, two tail. If it doesn't mention bigger than or smaller than, then it is a two tail test. What? 等一下。
like this one? I
No. I can't. I'm busy. Sorry.
just post the recording, so I wanna upload it.
What?
Post the.
Oh, okay.